Or wrestling. Dude, 40 pounds of muscle for like you took an ounce of nothing. Wrestle 200. Wait, what's the
Alright.
I will.
What? The ag students are going to be late to your class with the necessity to make sure you
Okay, alright. Okay. In your notes, here's what I like you to do. So you need to have your notes out right now.
I have the worksheet, I just don't know what notebook I put it in.
So. That's fine, just get to me by today. You can go look at it for later. Okay, alright. Here's what we're doing today. We have a couple things we need to work on. So we need to, number one, we need to practice a couple of these graphing sketches. I threw one of these at you at the very last second yesterday. I want to practice maybe 2 or 3 of these to make sure. Yes.
Oh, okay.
Okay, so we'll walk through what you need to look at, how you need to approach it, and then get to the right numbers. Again, usually I'm looking for one particular graph. It's kind of like one look to it. You can throw in some other stuff, but just make sure that you're following the general rules. So we'll walk through that here. I'm going to do 2 or 3 of these. We'll kind of see what you need. I don't think you'll need more than 2, but you never know. And then the goal is to then look at problems where the graph is not provided to you and you're supposed to find the limit. Okay? And I'm going to show you the shortcuts for to look at certain problems. Okay? So that'll be the last 2 or 3 questions. So we're going to go through quite a few. It's not like we're doing the 7-step method or graphing rational functions. Like this stuff should be kind of cut dry. This is how you're supposed to do it.
When's the test?
Test is next week, kind of end of the next week. I'm thinking Thursday or Wednesday sometime in that spring. Just if you want to ballpark it, because I want to do at least a 2-day review, and I don't know what day we'll get.
Tuesday.
What?
Tuesday, 2 weeks from now. Take it or leave it.
2 weeks from now.
Okay, all right. Let's kind of walk through this one. So here's the general rules on these graphs. I think you're going to have in the homework, you're going to get like 2 or 3 of these eventually. Now, here's how it works. It is one continuous graph. That's something you need to know. It's a continuous flowing graph from the left side to the right side. So don't think that there has to be breaks in the graph. There isn't. It's one continuous graph. And what you're trying to do is satisfy both conditions. So here's the idea. On the numbers here, these are the x numbers that you're approaching. So on this one, I'm approaching positive infinity. So I'm going along the x-axis, like to the right as far as I can go. Right? And then this one, I'm approaching 4 from the right side. That's what the little plus sign after it means. I'm approaching it from the right. And what you're doing is, once you get an idea of like which x you're approaching, the number that comes after it, right over here, is the number you're approaching as you go closer to that number. Okay, so if I go to the right, towards positive infinity, what number am I going towards?
Right.
I'm going towards 7 as I go to the right. So the idea is that this is what the graph would eventually look like. As I get closer to positive infinity, these numbers are approaching 7. Now, it could be from the top, I don't know, but I'm just making a guess right now. It could be the bottom, it could be the top, but this is the number 7, I think. 1, 2, 3, 4, 5, 6, 7, yes. Okay, so I'm approaching 7. It could be either from the top half or the bottom half. But as I go to the right, as I go towards positive infinity on the x's. Now, as I got closer to 4 on the right side, here's 4 on the right side. So I'm coming from this direction, right to the right. This thing is going towards negative infinity. So my y number is going down. So it's going to look like the picture I have, but it's just going to hug up against, like imagine there's an asymptote right here.
Oh, that's it.
That's it. That's your graph. You move on to the next problem.
I don't know.
It's meant to be one graph, not breaks, not weird stuff. You have to take the information they provided you and kind of make just a solid kind of guess at it. Okay,
What's
cool.
the first one again?
Okay, the first one, as I go to the right, as I go towards bigger and bigger numbers, it's going towards 7. It's getting closer to 7 on the y-axis.
Jared did it. I don't believe it.
So as I go to the right, this curve is getting closer and closer to 7. I'll hug up against it. So it's kind of telling me it's flattening off at 7. And then the other one is saying as I go to 4 on the right side, it's going towards negative infinity, so it's going down.
So my homework, if my arrows are kind of in the wrong spot, is that like...
What do you mean? How would they be in the wrong spot?
Because like, sometimes I don't know if it should be like this or if it should be like this.
Well, that's why you have to put both of these together. It prevents you from drawing it the wrong direction. Because one way it'll tell you to go towards 7.
Well, I mean the homework that's due today.
Oh, yeah, homework. That's fine. Because today is an educated guess. So you had to be in the general idea.
Wait,
There's a little wiggle room.
is there more homework?
Today there will be.
Like you're giving us homework
Yeah,
today?
today.
Okay.
It'll be due next Wednesday.
Oh, wow.
So you have a couple days. You don't need that many days. I'm just saying that because that's what review days are. Okay, all right. Were we good with this first round?
Radius is bigger.
No, that one was not horrible. That
Not
was so
bad.
easy.
Do another
They
one.
get harder though.
Okay, let's do another.
Make it a T.
They get hard, don't they?
Yeah, all right. Let's do another one here. All right.
These two?
Okay. Limit. As x approaches negative infinity, your function is going to go towards positive infinity. And the limit as x approaches 2. As approaches 2, my answer should be 1. And as the limit as x approaches positive infinity, my f of x should be positive infinity.
You changed the numbers. You're so
Oh,
small.
there's
Okay, wait, let me.
There's 3, and you have to use these all for one graph. One flowing graph.
Easy.
So you're pushing them all together to see where this graph is kind of bowing and flexing forward.
Confused.
Okay, all right. So let's walk through each step.
Not yet.
Okay, you want to try?
I just want a chance
Okay.
to think about it. My brain. Give me a chance. I haven't
Okay.
even started.
Take a few
Give him
minutes.
a chance.
Just go write it up on the board.
both sides. So it's going.
No, because it's approaching negative infinity and positive infinity.
On the x-axis.
Oh, on the X, that makes sense. That makes sense. Two, it's at 1. Just going to 2, it's at 1.
Up at an angle. You're always going over. Doing an up side.
That's like, this one you can't do.
Negative.
You got it.
Is a case.
It made sense before.
Really, George? Yeah, I confused myself again.
Okay, I think I might have it.
Yeah, it made
I
sense.
thought I understood it.
All right.
Approach is negative.
Okay. All right.
As x approaches positive.
So let's take a look at each side. It seems like you guys started on the left and you kind of worked your way because you went first one, second one,
Yeah,
third. All
definitely
right.
did.
So here we go.
Equals 1.
Okay. Okay, these are my x numbers. So as I get smaller and smaller x numbers towards negative numbers, my answer is going up. That's what it's telling me. These are the y answers I'm going to be hitting. So as I go this direction, as I go towards negative infinity, this graph is going up.
Yep.
Okay, because that's this first check.
Ever used orange before?
Okay, as I go to the left towards negative infinity on the x-axis, my answers for the y-axis will be going up towards positive infinity. That's what it says.
Is it a parabola?
Yes. Now, the second part of the graph, second piece, as I get closer and closer to the number 2 on the x-axis, 2 is over here, I'm going to be getting closer and closer to the number 1. So it's going to be coming down, and it's going closer and closer until it hits 1. And then it's going to go back up because if you read the next piece, as I go towards positive infinity to the right on the x-axis, this thing's going up towards positive infinity. So the graph will continue to go up and not stop.
Spooky colors.
So there's like a dot.
That is Halloween colors to the max.
It touches the 2, correct?
Because I'm scared of that.
Yeah, so as you get close to 2, it's going to hit 1. Or you can put an open circle there, but I'm going to assume that these, because the directions say these are flowing continuous graphs, so there's no holes. Okay, questions with how I pieced it all together?
No, let's do another one like that.
Another one?
I couldn't figure that out.
All right. I'll put another on the board. I know some people are still writing this one down.
Didn't have to be so high.
What was that?
That orange part didn't have to be so high up there. It could be down closer to
Yeah.
axis.
It's just eventually, if I zoomed out far enough, it's
That's the way I imagine you're putting it, like straight across. I don't know if that works or not.
like kind of like this.
Yes, exactly.
That's fine. You're in the ballpark.
More even ball.
Okay. So far, it's good. Let's try another. Okay. Now. Okay. Again, assuming that this is a flowing continuous graph, There's no breaks in the graph or anything like that. All right. We got to piece this stuff together. So, as the limit, as x approaches -4 from the right, my function will be -5. As my function approaches the number 3, it doesn't exist. And as the limit, as x approaches 10 from the left, I'm going to hit 1.
Okay, so give me a second.
So there's gonna be an open circle.
Could be an open circle,
And the
but,
top one and the bottom one together
but
is
the
open
graph
circle.
says it has to be continuous. So there can't be any open circles. So you gotta somehow make this a graph that is continuous and flowing.
Well, can't have an open circle and just keep going?
You can't.
Can, but that wouldn't be a continuous function. That would be a discontinuous function. Right? There would be an,
And just because it has a positive or negative on the backside does not mean it's ending there, correct?
no, it doesn't.
Okay.
That just means it's coming from the left.
Yeah. Left or the right side.
I don't have graph paper. It makes a lot of
Now
Let me
again,
go get you some graph paper, please.
Okay.
now, again,
Hey, Jake,
we're just making
I'd like some
educated
Can I
guesses.
also have some?
You can grab one more also.
You can bring it up for the whole class. Sure.
I brought 20 for the whole time.
I have like just big piece of graph paper that just grids the whole way across the paper. I mean, that's what you want.
Thank you, sir.
Here you go, here you go.
Oh, you missed Isaac. Shake right here.
That's all right. We'll pass some.
I'll come back. You're your last.
Okay.
What's on one?
I would take one if you were to give me one.
So this one starts down.
Brady,
I make my own little.
I don't know. These are, I don't understand.
Of course I did.
I don't.
Go.
Like the whole different
Oh,
negative,
-4.
positive,
Okay, so
infinity stuff
as
confuses me.
X,
If it's not,
Oh.
I like being
it's
able to
-4
graph
to the
it.
right.
This is where you have to kind of piece the parts together. That's what we're trying to do. You're definitely smart.
I
Once you see, you're like, oh,
Thanks,
I
Brad.
think you're making it way too hard.
I think I'm just not comprehending. Like
That's
the
a real-
little parts of it.
Yeah.
technically,
Change that.
because then it doesn't exist.
And I'll change it.
Calculate.
That's how that works.
It's one.
I will find out.
I don't know how you do it, Chad. How I do this?
Yes.
All of them.
You already got it?
Ward said that's one version of it.
Yeah, because this, it's very open-ended. You can draw different looking pictures and still be right.
Kitty cat.
As long as you meet two of the conditions, the third, just the middle one, you can do whatever you want.
As long as it's flowing.
Yeah.
Right, Jared.
You can't make it.
X approaches 10 from the left side.
Oh, yes.
Okay, I just don't know how to do the 3 one.
Yeah, that's the one that's very open-ended. So there's a couple different ways you could show a graph that wouldn't be, that'd still be flowing, that wouldn't have a limit right there. There's a couple different ways you can show it. So, just depends on how you want to sketch it. I've seen already a couple different ones. So.
Well, I'm just gonna make an S, kind of.
You just
Mine quickly.
Oh, you're just kind of like mine, I guess.
Yeah, I mean that would technically.
Jared, let me see that. I've got
It'd be definitely a different graph. It failed to be a function.
Or his.
That would definitely that would probably throw a big kink in the plan. I mean, in theory, it doesn't have a limit.
Just turn it into that.
Don't worry. Come here, bud. Hey, did somebody by chance take my best somewhere and write their name on it? And they-
You definitely just did that right.
Mine does not look
Period.
anything
I'm gonna
like
check
that.
that.
How could it be?
How do I insert that?
and not
Is this my homework?
That works.
Brandon?
The middle is where you kind of lost it a little bit. But I understand what you're saying. So, because you want to keep this graph one flowing graph the entire time, but you got to meet these conditions.
That was.
You most definitely can. So how do you do that?
You can.
But
Then it would be a vertical line and it would break the function.
No.
So those are basically.
Mine's just gonna snake its way down.
Vertical lines
You can only see
would
four
work.
sides.
It would be a vertical line. But it would fail to be a function, right?
But how do you get
it
a
has-
math equation to
yeah,
get
so-
to spit out two different answers?
It doesn't
Same
have to
input.
necessarily be two. It
He's
just
being so.
it just has to break the idea of what a limit would be. So there was something I talked about yesterday that would guarantee it. I don't know. So
Is this hard or is this tough?
this
What?
not too bad.
Yeah, this is pretty.
It's not too bad. It's not hard. It's not tough.
The thing
What,
is,
you struggling?
I meant, is it harder to?
Oh, where you kind of just do a really jagged thing in there.
What are you looking at?
I don't remember.
Oh.
Yeah, you said that it came and it couldn't actually spit it out, right?
Yeah.
Because it came from two different angles.
Well, that's it.
So according to the calculator, this point does not
Yes,
exist.
that would be one. Yes.
Which point? The 3?
But we're not
Yeah, and I'm saying this is 3 and this
So
somehow.
is
Doesn't, you don't need to be.
easy or-
There's just a couple rules we talked about that could spit out a does not exist there.
We're not calculators.
I don't mind.
Okay,
So is this easy or is this hard?
This is easy.
that's easy.
This, I don't understand.
Okay, so let's walk through it. So, okay,
There's gotta be a
okay.
point.
First, let's just talk about
That has
what
to
we're
be
looking
it.
at here. 'Cause
It's
this,
not that.
hey, shh. I have people that are getting confused just on the lettering, so I need everyone to kind of pay attention here. Okay.
Because you can't have something.
Okay, we are approaching -4 on the x-axis, and the plus sign after it means I'm approaching -4 from the right side. So imagine I'm coming up on -4 from the right side. That's what it's saying. Your answer for the graph, or the graph will be up or will be down at -5. So there'll be at least a dot at -5 when you hit -4 there. So that means as I approach, I better be hitting -5 when I approach -4 here on the x. So here's -4. My graph at some point, I don't care how, but you better be approaching -5. I don't care how you do it.
-5?
What? It better be hitting or passing through -5, yes. Or at least going towards it. Does that make sense?
Yeah.
Now, as I get to the number 3, now, the 3 here, since it doesn't have a plus or minus sign after it, we're approaching the right and left side together. The limit will not exist there. Now, you're thinking, well, Ward, I can't have a break. You said it has to be a flowing continuous graph. There's a couple different ways you can show that it would fail to have a limit there. One way, and Morgan, I think you drew it earlier, how did you draw it?
I don't think I did it right, but
Well-
like you can look at it.
But what was it, how did you draw it? What was your initial instinct?
It's like a,
Yeah, a super sharp point, almost like a seagull kind of a thing, where she did it something like this. She made a really sharp point and then kind of went out of it. That would fail to have a limit because it's too sharp of an
It
edge.
could be anywhere at 3 though.
It could be anywhere at 3.
I just,
So I kind of missed 3, but so here's 3 coming up. I make a sharp edge and kind of come off of it. It's still continuous. It's still flowing. I didn't have a break in the graph, but that moment failed to have a limit because it was too sharp of an edge.
It's gotta go up to 1.
Okay, and now what you're saying is now I approach 10
At 1.
from the left side. So as I go from the left side on 10, I better be going up to 1. So this is just one graph.
That's 11.
That's 11. This is just one sketch of what I'm doing here, right?
whoa, 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 whoa.
It's one sketch.
Technically, you can do it anyway.
I could do it anywhere I want.
You could have another one.
I could have had something going up here and then just coming back down.
Yeah, my way
Because
was
it doesn't tell me where I need to be. I just need to be at certain locations. I need to meet the limit at that moment.
So you just have to go through the drawing.
That X with the arrow should be 3.
That is drawing, whatever.
Okay, let's do it now. What is that?
Now, okay, hey, here's something else that I noticed. Okay, so Morgan and I saw a sharp edge. Now, there's a couple other people that drew something different. So, what was your sketch?
So I went up from the -4 to -5
Okay.
a little bit.
-4, you went up,
I shot straight up,
shot up.
went straight down, and then curved back up to.
Okay, so that was another type of graph. Again,
psychopath.
so here was his graph, okay? Because he was going to approach 1 at 10. He went this way. Instead of going up, instead of going down, he went up, and then what he did is when he got close to 3, he just made a really quick jagged motion and then leveled off.
Yeah, you did.
That's pretty funny.
That looks
Okay.
like your heartbeat.
Yep. Because anytime you have rapid oscillation in a graph, like a heartbeat or a sine graph, but you really compress it really tight together.
Seismograph.
Sure. That idea. As it oscillates up and down, you can't pinpoint where it will be at any specific moment. It's getting too close together, and it would fail to have a limit. So that was a clever way to do it. But it was also like something you said, also was, it's almost like a vertical line there. It's really close because I can't tell where it's going to be. Does that make sense now?
That's my favorite type of roller coaster.
Okay.
Just immediately. Yeah.
All right. Now, again,
Dad.
kind of like a roller coaster. Part about this is not just looking at what numbers you're supposed to be approaching. It's getting that idea of like, how do I just make a random sketch that meets all 3 criteria? So what I do is I just start with the first one, make sure that I met that criteria. Then I go on to the next one and just try to connect off of it. And then try to meet the next criteria. So if it doesn't exist, try to make something that doesn't exist. Oscillate or come to a sharp edge or something. But again, these graphs are supposed to be flowing and continuous. So make sure of that. Now, they could put stipulations in there, but they would type before the problem. They'd say, for this graph, this is a discontinuous function, so there's going to be a break in the graph. And then you got to go meet that stipulation. Okay, questions?
One more.
One more?
Jared, if you like those kind of roller coasters, there's one called the Grand Canyon, but it's more like there's no seat or anything. You just go off the edge.
All right, here we go.
You'll love it.
I'll make sure to take a horse out there.
On the way down, you would love
Horse. He's taking a horse and him.
Okay.
it. The poor horse.
Limit as x approaches 5 from the left. My answer is going to be 6. And as the limit, as x approaches 10, as approaches 10 from the left, I'm going to go to positive infinity. So there's 2. Flowing graph continues.
Guys, I got this.
So I'm approaching 5 from the left side. Better be getting up to 6. As I go from 10 to the left side eventually, it should go to infinity.
That's easy.
These are meant to be.
Funny.
Ha, ha, ha. Not easy.
You got the whole class.
Make me mad.
Isn't it just that?
Again, it's super open-ended. Don't feel like one graph is necessarily the end-all be-all. It's not. You could have, everyone in this room could have a different looking graph, but it meets these stipulations and it's still true. You just have to meet those 2 stipulations at those moments.
Oh, it's not -5, it's 5, but.
Yeah. So you're approaching 5 from the left side, then you're going to approach 10 from the left side. That's what the little negative sign after it means. It's like a little notational thing.
I just have to tell you.
Why'd you go that way?
Huh?
Still right.
I went the other way. I went the opposite.
Oh no.
We had
That's not
one over a
negative
couple
10.
times. That's right.
No, it's not. I don't know what you're doing.
Up to plus all.
So it goes like that. Maybe. I don't know.
Dude, our senior banners I think look sweet.
All right.
Yeah. Just looks something like that.
Might be biased.
Okay. All right. I'm just going to make a sketch, what I think it looks like. It could be different than yours. I want to approach 5 from the left side, and it better be hitting 6. Here's the number 5. That's 1, 2, 3, 4, 5. And I better be hitting 6 at that moment. Something like that. Okay? Better be hitting 6. Then as I go to 10 from the left side, here's 10 down here. I'm approaching it from the left side, from this side, it's going towards infinity. Positive
You don't even
infinity.
get my calf muscle.
Done.
That was the best part of everything. My calf muscle looks wild.
You can do what?
God dang.
It's got to kind of flow.
See, Jake, this works.
Yeah, we want to have a continuous graph. Now, here's the thing. I don't know what happens over here. You could have anything on this side. It could go down, it could go up, it can oscillate a bunch after it.
Look at that.
I just don't care. I just want to know that when I hit 5 from the left side, it was going to hit 6. And as I went to 10, it was going towards positive infinity. That's all I care about. Question.
Can you? Okay, so like when you hit 4 from the right side, and it goes off. From
Why?
The left.
It's my hand.
Left, right. Right side, left side.
Ryan, I'm about to kick your ass again. You just played me in cup long? Or is this a long time ago?
left side and or right side.
That left side, like, whatever after it?
Oh my gosh.
Yes, but this language has to make sense.
Watch it.
I don't
Oh,
know if you
that's
hit
me.
this from the right side.
Look at that.
No rules have to be consistent.
Yeah, because you're just flowing. It's just flowing around.
So then that one, we're hitting it from the
Well,
left
looks like we
side.
are.
Yes, I'm hitting it from the left. So from the left, as I get closer and closer,
I prefer
am I
hitting
going
from
to
the
hit
right.
that dot?
Yeah.
Yeah, but I don't get.
Kidding, I don't
this is
hit
what I
anything.
don't get.
What do you?
Because like this one, the arrow going down that way and we hit it from the right
I
side.
just get hit by my
That arrow
father.
goes to the left side, so
Right,
to
and
me
you
it
endorse
makes
the
sense to go
singular
to that.
thing.
Like swoop down like this? Yeah, do that. Like this? You want to do that like that?
It's like calling someone it.
Here, come here, draw.
Identify as a male or female.
What is your sketch?
War people.
It's probably not wrong.
Like I do approach it from the left, like you check.
Numerically,
You're
okay.
acting like that.
Yeah, that's fine. You're flowing, and you're gonna hit as you come from the left side. You're gonna hit that number, right? You're
But I don't
fine
care why they're all on that side.
because the graph has to continue, right? So I don't know what's gonna happen over there. I just drew an arrow because I don't know where it's going.
No.
Yours is fine. Mine was fine. So that's the problem.
See what I mean?
Must have
Like,
been Isaac, it must have.
I thought the same thing.
Hey, and it's fine. It's right.
I think I covered. It's different.
Is this what the homework is?
But it also makes sense. That you bro, so I don't think I would get it. I wish Kevin would have done
No,
his
you can start wherever you want.
Kevin's
As long as that graph was gonna sit at
I like that it's easier because it's so extended, but it's harder to know if I got it right.
Yeah, and that's the thing. Like I have to check. Everyone's picture could be different.
Exactly.
Yeah. So, hey, so I want to just show one more graph of this because I think the confusion is like, hey, you're showing different graphs every time you show a picture. Yeah, because there's an infinite number of pictures I could have had. Like Vanessa had a completely different picture than me, and it was totally fine. Her picture looked like this. Okay? All right, here is Vanessa's picture. She was approaching 5 from the left side, and she knew she had to hit 6 up here, right? Her graph looked like this. And then when she got close to 10, she took off.
You psycho.
It's fine. She met every stipulation, right? It's a completely different looking graph, even though she met every stipulation, and it's fine. It's open-ended.
Beautiful.
I like it. It works. Jamie, you had one picture that looked very close to mine. It was just going a different flow. Fine. It was fine. The graph worked because you met every stipulation. You hit the right number. You went the right direction eventually for the tail. Yeah. And that's the hard part, I think, to wrap your head around. It's like, there's an infinite number of graphs I could draw. I just have to meet certain stipulations at any certain moment. Okay. Now, we have one more example to go through here, and I want to talk about it. We haven't really seen any of these yet, so I want to make sure you guys get to try one of these out, or at least see it. All right. My goal is to do about 2 of these, so that's what I want to see here. All right. All right. Here's the first one I'd like you to have. Okay. Function. X to the 5th plus 4x to the 4th minus 9.
Disgusting.
No, why? No.
That is not what we're used to at all.
Hey, I know.
It has 4 turning points.
Okay.
Good. It's
Now.
y-axis at -9.
Okay.
It's not symmetrical.
Okay. As the limit as x approaches 0 for f of x, I want to know what number that is. Say it.
You just replied.
9.
It was 9. It was -9
Those are easy.
because that was a y-intercept. If I was looking at this graph and as I approach the x-axis or the y-axis at 0, as I approach x is 0, that means I'm looking for where the y-intercept is. The y-intercept was -9. You made an educated guess, that's the correct answer. They're going to ask you to evaluate a function at certain moments. They're going to give you a function and say, hey, as you get closer and closer to this number, where would your graph be? Well, here's the trick. Just plug in 0. See if it
I'm
works.
done for today.
Where did you find that neighborhood?
I'm checking
So
out.
we just
plug in
checking
0.
out.
So say it's a different number, we just plug that in.
Yeah, plug it in.
Boom.
And see where it spits out.
See, that's simple.
So if I wanted you to approach, Erica, pick any number you want. 2. You just plug in 2 and tell me what number you're going to
For
get.
X?
So for X. So this would be 2 to the 5th power plus 4 times 2 to the 4th power minus 9. 2 to the 5th power is 32. 2 to the 4th power is 16 times 4 minus 9, that's 64 plus 32. And we're going to subtract 9.
No.
So,
87.
To draw these, right?
no, they're asking for what is the value at that
86.
moment. They're having you do a quick
86.
guess what it is.
It's 86.
86, okay, fine.
No,
Now-
96.
Okay,
Minus
now,
9 is what, 87?
whatever, I'm moving on. Now,
It's
here's,
87.
Yeah.
all right,
I said 87 5 minutes ago.
Yeah.
And then
okay,
you said like 53 or something. I don't even know what you said.
I said 50.
okay. Next one, this is a more challenging one.
No.
Limit. As x approaches negative infinity. Say it.
Down,
Why?
because it's an odd power for leading.
Exactly. Now you gotta start putting in the rules we talked about for end behavior. When we did the graphs originally, those
So you start at
functional,
-9 and go down.
it's an odd-based graph.
Right?
The odd-based graph, the tails go this direction. So as I went to the left further and further and further, an odd-based graph, the tail on the left side goes down, the tail on the right side goes up.
But it hits 9.
So it doesn't hit any specific numbers. In the middle, yeah, I gotta hit -9 some point in the middle. So maybe the arrow's going this way, but I had to
Can
hit
I go
-9.
try to find my homework?
So as I go this direction, I'm going to negative infinity. It's going down on the left side. If I said positive infinity, now I'm going to the right, well, I'm going up on the right side. So you have to like interpret. Now, yeah, so now,
Parabola, wasn't it a parabola?
this is an odd-based graph. It could literally do something like this. It could like oscillate a couple times. It's probably hitting the numbers. It's an odd power, so it doesn't necessarily have to be like a parabola. Parabolas are more even-based. So it's gonna just have some weird turning points. This thing could have potentially 4 turning points. So, now,
Wait, so if x to the 5th, there's 4 turning points, right?
yes.
So does that just mean there's 5 sides? Is like that what the 5th means? Is the sides there's 5?
There's potentially 5 x-intercepts.
Okay.
So, I don't know if that's 5 walls. I don't know if that you can consider it that way.
Well, I was just saying there's 2 turning points or 3. Okay.
Okay, sorry. All right, let's do another one here. Okay.
My neck just stopped.
Dude, give it to me.
No, we gotta put it up on the wall.
Is it possible? The can is longer, it's less stout, so you can just crush it.
Okay, this is my last problem.
I feel like
If you can get this one, you'll understand any one.
Oh, he had that.
It's a fraction. Okay, we just did these. There was that whole worksheet we just did.
Yeah, about that.
Okay? I want to approach positive infinity as I go to the right, further and further and further. What's going to happen to this graph?
What?
Say it.
1/3?
You're absolutely right.
Christ.
Why?
Because
Oh,
it's
it's
a
not-
you can show the top and
bottom.
Yeah, it's got the same power. It's got x to the 5th. It has a horizontal asymptote.
what the?
So, you have a horizontal asymptote when you divide those numbers, the leading numbers. So that, all the horizontal tells me is where the end tails go. That's what I needed. As I go to the right or left, it's gonna hug up against 1/3. Doesn't matter what side you're on. I'm gonna hit 1/3 because it's taking the front numbers and dividing them. So no matter how it's drawn, I don't care. I'm approaching 1/3 on the right side, no matter if it's up or down from it, but that's the answer I'm looking for. Even on the left side, if I went to negative infinity, it's the same exact answer. That's why we have horizontal asymptotes. Now, if this is a linear-based problem, I don't know where it's gonna go. It's gonna be kind of going up or down. You just have to know which way it's tilted. If it's a line, is it going up or is it going down? So if you can figure that stuff out, now we're starting to like look at long-term distancing. It should hopefully start to make sense.
So you can come from the other side too.
Yeah, I mean, yeah, this graph could have done this.
Yeah.
I'm approaching 1/3 no matter what.
Wait, like.
All right. Okay, here's your homework. It's gonna be